This is a simple problem based on kinematics. Let's solve it together. So a boy standing on viewing platform of the Qutub Minar. I'm sure you would have visited this popular tourist site. Yeah. He then throws a ball vertically downwards at 2 meter per second. So the initial speed of this ball is 2 meter per second in the downwards direction. If the platform is 72 meter above the ground, the speed with which the ball hits the ground is. So you have to find out the final speed with which this ball is going to strike the ground. Well, you obviously know that just as it is about to hit the ground, it will be moving in the downwards direction. So for simplicity, let's assume the downwards direction to be positive. Okay, this will be the sign convention that we are going to follow. Now what has been given? The height at which the ball is located initially is 72 meter above the ground. So this is 72 meter, right? The initial speed is 2 meter per second in the downwards direction. So u is given as plus 2 meter per second, right? And the displacement will now point downwards. So that will also be positive, right? So displacement that this ball has to cover is plus 72 meter, and g is given as 10 meter per second squared. You have to find the value of v. Now, which equation of motion can you use here? Or can you use equation of motion or not? Well, you can use equation of motion when the acceleration is constant. So in this case, acceleration is constant, which is g. So you can use the equation of motion. So out of the three equations of motion, which one are you going to use to find out the final speed? Well, yes, the third equation of motion, which says v squared minus u squared is equal to 2 into a into s. Let's put the values of all the variables, but do remember that we have to follow this sign convention, that is downwards as positive. Now with that, this v squared, and this will become u squared, it is 4 plus 2 into 10 into 72. And then you have to take the root of this, which is going to be, so this is 1444. And what is the square root of this number? Well, you can find out. I remember this. This is, I think, 38. So the final speed with which the ball is going to hit the ground is going to be 38 meter per second. And option B will be the right answer. Now let's solve this question based on relative velocity. I'm sure you would have solved a lot of questions based on a swimmer crossing the river, the shortest time, shortest path, drift, and so on and so forth. So let's revise those concepts once again in this case. Now in this question, a man is capable of swimming at 10 meter per second in still water. Now you know what this velocity is, right? This is the velocity of the man with respect to the river. And this is 10 meter per second. If he wants to cross a river flowing at 5 meter per second, and as clear as that, this is the velocity of the river with respect to the ground. This is 5 meter per second. And reach the opposite shore in the least possible time. Then how far along the river will he drift if distance between the shore is 100 meter? So in this case, this is how the situation looks like. The width of the river is 100 meter. And this man has to cross this river in the least possible time. Now, if this man has to cross the river in least possible time, then don't you think he should put the whole effort in just crossing the river? Right? And in that case, he will be able to cross the river in the least possible time. But this will also be the case, do you think, where the man reaches the opposite end or directly to the opposite side of where it started from? Well, no. That case would have been the case of the shortest distance. This is the case of the least time. And as I just told you, for this one, the man will have to swim in the perpendicular direction as observed by the river. And then only he will put his whole effort in just crossing the river. So that is why in the diagram, as you can see, the velocity of the man with respect to the river is in the perpendicular direction as shown. And you already know that the velocity of the man with respect to the ground or as observed from the ground is equal to his velocity with respect to the river plus the velocity of the river with respect to the ground. So as observed from the ground, it will seem as if this man is going along this direction, making an angle theta with the perpendicular. Now, first let's find out the time taken by this man to cross the river. And we will do this by going into the frame of the river. So if you observe from the river's frame of reference, then the displacement that the man has to travel is 100 meter. And the velocity of this man with respect to the river is 10 meter per second. So the displacement will be equal to the speed of this man with respect to the river into the time taken. And from here you will get the value of time as 10 seconds. Remember, we are doing this from the reverse frame. So it will take 10 seconds for this man to cross the river. And what do we have to find? We have to find the drift of this person. Well, now think about it. As observed from the ground, this person has two velocities, one along the perpendicular direction and one along the river. And the summation of these two velocities is the velocity of the man with respect to the ground. Which means that this component is responsible for crossing the river. And this component is responsible for drift. So to find out the drift in this case, you only have to apply one simple formula, which is drift is equal to, and we are observing the person from the ground now. So the drift will be equal to the velocity of the river with respect to the ground, which is 5 meter per second into the time taken for this person to cross the river, which is, we just found out to be 10 seconds. And 50 meter is the drift of this person, which means the distance BC is 50 meter. And that is going to be your final answer. Therefore, option C will be right. Now I'm sure you will find these kind of questions really simple. So let's solve this one. A person of mass 60 kg is in a lift. So the 60 kg is the actual mass of this person. The change in the apparent weight of the person when the lift accelerates up with an acceleration of 2 meter per second squared and then down with an acceleration of same 2 meter per second squared. So let's solve this quickly. But we will go to the lift's frame to solve this one. As observed by this frame, there is a force of gravity acting on the man in the downwards direction, which is equal to m into g, and the normal reaction, let's say N1, is acting on it in the upward direction. The reading taken by the weighing scale will be N1. And because this lift's frame is a non-inertial frame of reference, so we have to introduce a pseudo force. So the magnitude is easy, m into a, but what will be the direction of this pseudo force? Well, the lift accelerates upwards. So the direction of pseudo force must be downwards. So the pseudo force is going to act in this case in the downwards direction, and the magnitude will be m into a, where n must be equal to mg plus a, because from this lift's frame, this man is in equilibrium. And there you go. So this is N1, and we have the value of N1 as, let's put it, so the mass is 60, G is 10, A is 2. So this is 12 into 60, or let's say 12M, right? We'll put the value of M later. And now let's go to the second case where the lift moves down with the same acceleration of 2 meter per second squared. As observed from this frame, there'll be a force of gravity, M into G, and the normal reaction, let's say N2 in this case. And the pseudo force will be acting on this man now in the upward direction, right? And the magnitude is going to be M into A. Again, from this frame, this man is at rest. So the total upward force must be equal to total downward force, and then only it is possible. So from here you get the value of N2, that is the apparent weight in this case, as mg minus a. So g is 10, a is 2, that becomes 8 into m. So we have both N1 and N2. Let's subtract them. So N1 is 12m and N2 is 8m. When you take the difference, you will get 4 into m. And 4m will be 4 into 60, that is 240. And what will be the unit? Kg or Newton? Yes, Newton. So this will be 240 Newton, and that is going to be the final answer. Therefore, option B will be correct. In this case, we have a spring balance attached to the roof of a moving elevator, which is indicating 80 kg weight as the weight of a 120 kg body. So the real weight of this object is 120 into g in Newton, and the apparent weight is 80 into g. So the apparent weight is lesser than the real weight in this case. So can you tell me in which direction this elevator is accelerating? Upwards or downwards? Well, the same thing applies here also. The reasoning that we were using for weighing scale applies for this spring balance too. So you know that when the lift is accelerating in the upward direction, then the apparent weight increases. In this case also, if the lift or the elevator accelerates upwards, then the tension force within this spring balance will increase. And if the elevator is accelerating downwards, then the tension force or the spring force will decrease. So what has happened here? Well, the tension force has decreased, right? Because the apparent weight is now 80 g and the real one is 120 g. Therefore, you can easily guess the direction from here. The direction must be in the downwards direction, right? So there we go. We have the answer to the first part of this question. But if I look at the options, then I can see that we only have to find out the magnitude of acceleration. So let's do that. We will go to the lift's frame. So the person that you see here will observe the block that is hanging from this spring balance with respect to this person. So what will he observe? He will see that there is a gravitational force acting on it, and how much it is? This will be the real weight, that is 120 into g. And there will be a spring force developed, which is given as 80 g. And what else? Well, this person knows that the frame that I am inside in is a non-inertial frame of reference. So he has to apply the pseudo force. And the pseudo force is going to be equal to, so if the acceleration of the lift is down, the pseudo force will be in the upward direction, and this will be m into a. And what is m? The real mass is 120. So this will be 120 into a. And now with respect to this person, the block is at rest. Therefore, all the forces acting on it must equate to 0, which means that the total upward force must be equal to the total downwards force, right? So what is the total upward force? It is 80 g plus 120 into a, and this must be equal to 120 into g. Now remember this, if you have imagined the direction of the acceleration to be upwards, then you will get from this equation the value of a as negative, which must tell you that you have assumed the wrong direction. Okay, so it works that way also. Mathematically, you can find out if you have assumed the right direction or the opposite of the right direction. Okay, so from here we have assumed the right direction, therefore we'll get the value of a as positive, and the value of a from here is going to be, so 120a will be equal to 40g, and a will be g divided by 3 meter per second squared. So I hope you understand this, and the value of acceleration from the options will be 10 divided by 3, that is 3.33 meter per second squared, and option D will be the right answer. This question is really awesome, and you will have to use your imagination to understand it in a better way. So let's start this. A sphere of mass 1 kg rests at one corner of a box. The box is then moved with a velocity which depends upon time, or which is a function of time, as 8t I cap minus 2t squared j cap. So it has both the components, one along positive x and the other one along negative y, right? The force by sphere on the box at t is equal to 1 second is, Now, don't you think that the force applied by the sphere on the box will be the same as the force applied by the box on the sphere? Yes, by Newton's third law. And if we can find out the normal reaction applied by the box on the sphere, then we can find the magnitude of it, and that will be our answer. So let's talk about this. In which direction will be the normal reaction? Well, if this ball or the sphere rests like that in the lower left corner of this box, then the left wall or the left surface of the box will push this ball towards right. And the lower surface on which this ball is resting will push it in the upward direction. And therefore, the resultant of these two will be the net normal reaction that is applied by the box on the ball. And you can see the direction. This will be the direction and it will be on the same plane, that is the XY plane. Now, the next interesting question is that how this box is moving. So let's assume that this is the box, okay? And this is the positive x-axis and this is the positive y-axis. So I want you to find out if this box is moving like that or like this. Well, use your imagination, take your time. How will you approach this question? Well, the indication of motion of any object is given by the velocity function. And you see that the velocity function is at I cap minus 2t squared j cap. Now, if you put t is equal to 0 in this function, then you get the velocity as 0, which means that at t is equal to 0, this box along with the sphere both were at rest. But as the time starts increasing, then can you see that the x component of the velocity will keep on increasing, right? And this component will be responsible to give the velocity to this box along with the sphere towards right or towards positive x. But how about the y component? Well, if you increase t, then the y component, that is the minus 2t squared factor, also increases. But this component is directed along negative y-axis, which is indicated by the negative sign, right? So therefore, the velocity of this box is increasing along positive x and along negative y. And therefore, this box will move like that. So I hope this is clear to you, right? And now with this velocity function, we can find out the acceleration, which is dv by dt. Now let's find the acceleration in the vector notation. So if you differentiate this velocity function, you get 8 I cap minus 40 j cap, right? So this is the acceleration function. And at t is equal to 1 second, the acceleration is going to be 8 I cap minus 4 j cap. So if you look at the situation, then let's assume that the box is at this particular location at t is equal to 1 second, where its acceleration is like that. Why like that? Because its x component is positive and its y component is negative. So this is the acceleration, let's say a vector. Now let's observe this sphere from the box frame of reference. So I have taken a boy inside this box who is observing the sphere. Now with respect to this boy, there will be few forces acting on this sphere. Let's find out what are those forces. Well, one obvious force is the force of gravity, let's say Fg, which is pulling this sphere in the downwards direction. And we can find this value of Fg in vector notation. So this is going to be m into g downwards. M is 1 kg, right? And g is 10. So this becomes minus 10 j cap. Okay. And now any other force that you can think of? Yes, we just discussed the normal reaction acting on this sphere, which will be in this direction. And we have to find this. So this is N. And a pseudo force will come into the picture because this frame is non-inertial. And can you tell me the direction of the pseudo force? Well, the direction of acceleration is like that. So therefore, the pseudo force will act in the opposite direction like this. And let's say this is F pseudo. So let's call this F PS. Okay. And as observed by this boy, the net of these three forces must equate to 0 because with respect to this frame, the sphere is at rest, right? And now we can also find out the pseudo force in the vector notation. Well, how? You know that pseudo force is going to act in the direction opposite to the direction of acceleration. And we know the acceleration vector, which is 8i cap minus 4j cap. And if you want to find out the vector in the opposite direction, you take the negative of it, right? So imagine this. 2i cap is a vector pointing rightwards. And if you want a negative of this, then you take minus 2i cap, which will point towards negative x-axis. So this is the same logic. And the pseudo force, that is m into a, will be m, that is 1 into acceleration, and we have to take the direction as opposite to this vector. So therefore, I'll attach a negative sign here. So this becomes minus 8i cap plus 4j cap. I hope you understand this, right? So the logic is that this vector is pointing in the opposite direction as of the acceleration vector. Therefore, I have taken a negative of a. And this is the pseudo force. And normal reaction is, let's say, n vector, which we have to find. And what is the logic? The logic is that the net of these three forces, that is the gravitational force plus the pseudo force plus the normal reaction, must be equal to 0, right? So let's put the values one by one. This is minus 10j cap plus this is minus 8i cap plus 4j cap. So let's write it here. Minus 8i cap plus 4j cap plus the normal reaction force, and this is equal to 0. And from here you get the value of normal reaction in the vector notation as this will be, so this is 8i cap plus 6j cap, right? And finding out the magnitude of this is an easier task. You only have to take, so the magnitude of this normal reaction will be under root 8 squared plus 6 squared, which will be 10 Newton. And that will be the force exerted by the sphere on the box. So I hope you understand this approach. And from this you get the value as 10 Newton. And that will be your final answer.
For more videos and live lectures on the JEE, click on the subscribe button now.